Hello. In this case, we're going to be finding the tangential velocity of a test tube being spun in a centrifuge, one of those devices that you might find in a lab or at a doctor's office, which is used to spin test tubes at a very high rate. In this case, 30,000 RPM, or 30,000 revolutions per minute. Um, all right. Now remember, the tangential velocity, of course, is the velocity of an object that's traveling in a circle, and so at any point along the circle, it actually has it's traveling in a circle, and so at any point along the circle, its velocity is actually tangent to the circle at that point. And so no matter where you are in the circle, the velocity is actually headed straight along directly tangent to the circle. And so the velocity is, of course, its speed and its direction, and tangent indicates the direction. All right, let's get rid of that and write down our givens. Okay, let's see. We're looking for the velocity, the tangential velocity, so we'll put that down as question mark. And it says it's being spun in a centrifuge at 30,000 RPMs. Okay, 30,000 RPMs, or revolutions per minute. Now that is how many cycles, or how many trips, how many circles, how many trips around this thing makes in 1 minute. That's quite a lot. Uh, but that is the frequency. That is how many cycles it makes in 1 minute. That's actually a non-standard. Unit. We need that to be in cycles per second, or revolutions per second. So let's go ahead and convert that. If it's in RPMs, let's see. You'll just need to divide by 60. I'll go ahead and show you the rationale for that. If it's 30,000 revolutions per minute, and we'd like that to be in revolutions per second, and so we need to put 1 minute and 60 seconds. And of course, when you do that, you'll see that your minutes will divide away, and so 30,000 divided by 60 will leave us with revolutions per second. And when you do that, you'll find out that that's going to end up equaling 500, not meters, revolutions per second. Okay, and so that is actually going to be our frequency. 500 revolutions per second. All right, great. Let's see. So looking for the velocity, we have a frequency, and then we have a diameter of 20 centimeters. All right. So our diameter is 20 centimeters. All right. Now there's two problems with that measurement. Number one, it's a diameter. What we usually need to use for our formulas is the radius. So let's go ahead and split that in half, and notice that that's 10 centimeters. Remember that our standard unit for distances is meters, so we'll need to convert that. Centimeters to meters is a quick little two-place bounce to the left. So 0.10 meters, and that's our radius. All right, at this point we just need to refer to our notes and find that the tangential velocity can be calculated from 2 pi r times frequency. So at this point, everything's very straightforward. 2 times pi times the radius of 0.1 times the frequency of 500. And when you do that, you actually will end up with 314, and our speeds, or our velocities, are always in meters per second. And so 314 meters per second, so that thing is whirling along at quite a good rate inside the little centrifuge. But, you know, that's what you got to do to get some of these chemicals separated sometimes, is spin around really quickly. All right, so that's how you can calculate a tangential velocity from a frequency.